not feeling well actually. Actually, I got flu start yesterday, but it's okay.
It's okay.
It's
Sorry.
okay. It's okay unless my voice can teach the student, so should be okay.
Okay, I can hear your voice clearly.
Oh,
So it's
okay.
okay.
Thank you.
Untuk mahasiswa silakan membuka kamera ya. Kita akan segera memulai perkuliahan dengan Ibu Hidayah. Supaya Ibu Hidayah bisa mengenal wajah-wajah mahasiswa Universitas Brawijaya.
Ya. Pasti comel-comel sekali. Cantik-cantik sekali belajarnya.
Comel itu apa, Bu? Cantik?
Cute.
Oh, cute.
Ibu Siti, berapa pelajar daripada Ibu Siti punya grup? Ramai ke?
Di kelas kami ramai, Bu. Di kelas kami untuk satu year itu 120. Ini nanti ada sekitar 40 pelajar yang akan ikut di kelas ini.
Okey. Adakah
Jadi
semua...
kami punya kelas A, B, C, D, Bu. Ini kelas D.
Oh, okay. So this class under Ibu Siti lah.
Yeah, for organic chemistry class.
Okay.
I also invite the students from another class if they have a time, they also can join.
Okay, same to me. If
okay.
I share with my student, if they want to join, then we can proceed.
Oke, baik, kita mulai. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih Bu Hidayah. Thank you very much for your time. So today we have a class with Dr. Hidayah from UITM. Dr. Hidayah will give a lecture about carboxylic acid. Actually, the preliminary of this study, I teach this topic in a class, but you can give some deeper insight about this material. So we can proceed now, Doctor.
Okay, thank you, Bu Siti.
Okay, yeah. Yes, please. You can start now, Dr. Hidayah.
Okay, Assalamualaikum and selamat petang, selamat tengah hari. Is it, in Malaysia is 1 o'clock. I think in Indonesia now is 12, is it?
Yes, 12.
Okay. So I proceed for my lecture today. Thank you so much, Ibu Siti. Actually, Ibu Siti is one of our collaborator in terms of mobility, in terms of collaboration in project. Thank you so much for this opportunity to me. Okay, so without further ado, so I proceed for my lecture today. Okay, this is actually for carboxylic acid. I want to divide it into 3 parts for today's lecture. Okay, for the first part is you want to introduce the carboxylic acid and then proceed for the physical properties. Okay, physical properties of carboxylic acid. And then we focusing on synthesizing of carboxylic acid together with fraction of carboxylic acid. So I'm only focused on 4 parts in this carboxylic acid. Okay. Okay, so now here is the introduction of carboxylic acid. Okay, I want to highlight this is very important for carboxylic acid. You must know the structure, the general formula for the carboxylic acid. So we know that carboxylic acid, the most important, you must know the the functional group of the carboxylic acid, actually C double bond O, OH, and bond with 2 types of group, which is this one is alkyl group for aliphatic chain. And the second one is for aromatic that bond to our functional group carboxylic acid. So there are 2 examples for the alkyl and also aryl group. That's very important for you all to know the general formula of carboxylic acid. So now I proceed for the physical properties of the carboxylic acid. Okay, so there are 2 types of properties, especially for carboxylic acid. So we have the first one, we have boiling point for aliphatic carboxylic acid. So we know that the organic chemistry is the complex structure, but this one is referred to the structure which is having 1 until 10 carbons. So means that the structure is in the form of the liquid. Okay, so this boiling point actually increase with increasing the relative molecular mass, means that once your structure is become bigger, so your boiling point will increasing. Okay, so reason why the boiling point is increased due to the hydrogen bond. Okay, as you can see the structure, okay, we having carbonyl and also hydroxy group. So that's why when the structure of carboxylic acid is become larger, so means that boiling point will increase. Okay. So here is some of example that regarding on the boiling point carboxylic acid. So we have this one is carboxylic acid. Okay, we know this is the co-skeleton, the functional group carboxylic acid. And this one, there are no carbonyl, but the hydroxyl group is bound to this carbon. And this one having the carbonyl, but the both of the alkyl group is from the alkyl. So this one is carboxylic acid, this one is alcohol, and this one is ketone. So there are 3 examples to show regarding on the boiling point. Okay, as you can see here, boiling point for carboxylic acid actually slightly higher compared to this one hydroxyl, and also this one aldehyde or ketone. So the reason why the boiling point for carboxylic acid higher, actually I have mentioned from the previous slide. As you can see, this is the structure that I explained. Okay, this is C double bond O, and this one is OH. Okay, so this one for alcohol, there are no carboxylic acid. There are no carbonyl, sorry. Okay, as you can see, carboxylic acid will form the stronger hydrogen bond, okay, compared to alcohol. Okay, because this carbonyl actually having and provide the medium of the electronegativity is slightly higher compared to this one. Because for the hydroxyl group, there are no carbonyl group, and it means that so the electronegativity for this hydroxyl is slightly decreased or lower compared to this one. Okay, so this one is a high electronegativity, and then moving forward to this carbonyl group, which is also having the electronegativity. So that's why the criteria is the reason why the boiling point for the carboxylic acid totally increase compared to hydroxyl group and also aldehyde and ketone. Okay, this is the another reason, okay, why the carboxylic acid is slightly higher. For this one, the example of the dimer, okay, means the dimer means that involve 2 molecule of carboxylic acid. And this molecule is can form the hydrogen bond with another carboxylic acid. So that's why the structure we call as dimer actually increase the van der Waals between 2 of carboxylic acid. So that's why dimer slightly increase the boiling point compared to the single carboxylic acid, and compared to hydroxyl, and also compared to the aldehyde ketone. Okay. Now we look at the solubility. So actually for physical properties for carboxylic acid, we having 2 criteria. The first one, boiling point, and now is solubility. Seems to the carboxylic acid for boiling point, which is for the solubility, if you having the structure less than 4 carbon, okay, 4 carbon, it means that your structure having 2 carbon, 3 carbon is so easily this compound immersed in the water. Okay, so reason why, because of carboxylic acid group, C double bond OOH group is able to form hydrogen bond with water molecule. Okay, so in to answer the question, if the question asks regarding the briefly explain, okay, why the solubility and also in terms of boiling point carboxylic acid is slightly higher compared to the others. Okay, the main reason because of the co-skeleton of carboxylic acid, C double bond O OH. So that's why it's able to form a hydrogen bond with water molecule. So easily this compound to form the hydrogen bond when immersed in water. Okay, so the solubility of carboxylic acid in water slightly decreases due to the molecular weight is increased. So means that when you're having the structure is completely complex. So means that the structure is bigger. So what happened to the solubility? Of course, the solubility is decreased due to the larger structure. Okay, so the solubility of carboxylic acid, okay, not only immersed in water, but also we also having the solvent, okay, such as hexane, petroleum ether. So this solvent actually provide the non-polar solvent. Okay, so if in water, we know that water is polar, so this carboxylic acid can immerse. How about this non-polar solvent? Okay, the solubility of the carboxylic acid also increase when the carbon chain is get longer and get bigger. Okay. Okay, now we go through for the chemical properties for carboxylic acid. So the previous I mentioned for the physical properties, boiling point in terms of the solubility. But now is the acidity of the carboxylic acid. So we have several of the effects regarding on the acidity. The first one in terms of the carboxylic acid, we need to compare with alcohol and also phenol. Okay, alcohol is the aliphatic carbon that having the bond with hydroxy group. But phenol is the aromatic, which is having bond with the aromatic. Okay, so this carboxylic acid once dissolved in water. So what happened to our acid? So we dissolve in water and dissociate. Okay, when dissociate from this equation, we having this hydronium ion. Okay, and together with this structure RCOO minus when you dissolve this carboxylic acid in water. So we having two reasons. The first one regarding negative inductive effect. Okay, we focus on carbonyl group, right? Okay, so we didn't see any reason except for the carbonyl group. Okay, the second one due to the resonant effect of the carbonyl group. Okay, both of the reason are related to the carbonyl group because we know that our structure carboxylic acid having this carbonyl. Okay, so now we look at the strong negative inductive effect. Okay, the first reason. Okay, the shift in electron density from one atom to another will form a polar band. As you can see here, this is a carbon element. We know that carbon element in group periodic is positive electropositivity, okay, compared to halide group, which is we know that a high electronegativity. So having two different of the electron density. So what happened? The carbon, okay, when the carbon having the same charge and automatically the electron is expelled, okay, the same criteria, the same charge, of course, the charge will expel, okay, or repel. Okay, so the second one, in terms of when the structure having the halide atom, okay, we know halide atom, the group, okay, which is group electronegativity is higher. Example is chlorine. Okay, we having fluorine, we having iodine and bromine. So all of this actually the higher electronegativity in periodic table. So that's why chlorine, which is attract electron, okay, so because of it higher electronegativity. Okay, as you can see here, okay, we want to compare the carboxylic acid together with alcohol. Okay, you can see the atom, okay, weaken the hydroxy bond. So the carbonyl group can lose of proton readily. So that's why carboxylic acid is much stronger acid, okay, compared to this alcohol. Okay, due to this proton, okay, compared to this proton, as you can see from this structure, so for carboxylic acid having this carbonyl, but this one there are no carbonyl. So that's why in terms of the weakened, and this one is weakened compared to this one. Okay. Okay, next reason, the second one is resonant effect of the carbonyl group. Okay, when we call as the resonant effect, it means that you are having the two structure which is have the same molecular weight. Okay, this one same molecular weight, this one with this one, but in terms of the structure is definitely different. Okay, because we look like same, but actually the structure are different. Okay, so what happened to this negative charge is delocalized over two carbon oxygen bond. Two, this one carbon and this one oxygen. Okay, when you want to answer the question regarding the effect resonance, so the most important term here is negative charge delocalized. Okay, or delocalization or resonance stabilized. Okay, so this is the point to answer the question if the question asks regarding the resonance effect of the carbonyl group. Okay. Okay, there is here is some example question. Why the carboxylic acid is more acidic compared to phenol? Okay, we know that phenol is the hydroxy group bond with the aromatic group. This one is aliphatic. Okay, this one is aliphatic carboxylic acid. There are no aromatic compound here. Okay, so reason why, because carboxylic ion is more stable compared to phenoxide ion. So I will explain briefly regarding why the carboxylate ion is more stable compared to phenoxide ion. Okay, as you can see here, this is the structure which is phenoxide ion. Okay, phenoxide ion, this is in negative charge or minus. We have in carbo and ion, but different position in the aromatic. Okay, so the negative charge on the phenoxide ion actually delocalize onto carbon. So means that the electron only circleize in the aromatic. So that's why the phenoxide ion is less stable compared to the aliphatic. Okay, because as you can see here, electron did not go a flow outside from the aromatic. So that's why this aromatic is less stable compared to the aliphatic. This one is more stable compared to this one. Okay. Okay, so next in terms of the chemical effects on chemical properties is effect of substituent group on the acidity of carboxylic acid. Okay, we are still in carboxylic acid. We have the C double bond OOH. Okay, we want to see in terms effect on chemistry. Okay, this one is second effects. Okay, we look at the electron withdrawing group and together with electron.
The example of electron withdrawing groups like halide, like a chlorine, fluorine, and bromine.
Okay, exactly right. Thank you so much. Okay, so that's true. The example of the electron withdrawing atom actually such as halide. Okay, from the halide atoms, we know that halide atoms example is chlorine, bromine, iodine, fluorine. So all of this is producing the electron withdrawing. Okay, also we have another electron withdrawing group such as nitro. Okay, in the carboxylic acid molecule also withdraw the electron density. But because the key term to elaborate the effect of the substituent group actually in term of the withdraw electron density. Okay, so the carboxylic anion is stabilized. Okay, and also the acidity will increases. Okay, compared to phenoxide. Okay, phenoxide we know that the phenoxide ion is not stable, so that's why the acidity is slightly decreased. Okay, we having the different of scenario on the effect of the electron withdrawing group on our acidity strength. Okay, this one. Okay, as you can see, this is an example for electron withdrawing. We have iodine. Of course, we started with the CH3 alkyl group. We know CH3 is the electron donating. Okay, donate is it positive. Okay, so this one is negative, bromine, chlorine, fluorine together with nitro. Okay, as you can see here, okay, acid strength increases, okay, increases towards to nitro. It depends the position in periodic table. You can see after this the position location of the electron withdrawing for each of these element. okay, to determine the strength of the acidity. Okay, of course, fluorine is more electronegative compared to chlorine and having a stronger electron withdrawing effect. Okay. When we are apply in our project in terms of organic synthesis, we always are using the element of chlorine and also bromine. It's slightly stable compared to fluoro and iodine, and of course the price of this element is slightly expensive. Okay, and then we can see from here the table. Okay, the tables showing okay the number of halogen atom and also in terms their acid strength. Okay, if you can see here, pKa is a value for acid. If you register the code for the general chemistry, I'm sure you already learned regarding the value of acid. pKa having their own formula. Okay. Not simplify, we just give the value in this table. Okay, so now we having carboxylic acid as our core. This one is our core carboxylic acid. As you can see here, this carbon bond with one element of halide, chlorine, and this one 2 halide, and this one is 3 halide. Okay, so in terms of logical, okay, one halide actually having a high electronegativity. So what happens if you still add on more of chloride, more than 2-3 chloride in your carbon? So what happened? Do you have any answer? Ada? Siapa nak mencuba? From Brawijaya or UiTM?
Ibu izin menjawab.
Yes.
So if we add more chlorine to our carbon, the pKa will be lower, higher.
Okay, that's all. So exactly correct, but in terms of chemistry, because you related with the pH, okay, but the correct answer actually due to this element chlorine, when you having one chlorine, okay, this one carbon is high density of positive charge. This one is a high density of negative charge. So what happen if you have a lot of the negative charge? Okay, you having this one 3 electron negative charge, is likely the quantity of the electronegativity is more compared to this one positive charge. So that's why as you can see from this pKa value, acid value will slightly increase. Okay, it's become more acidic. Okay. So the term here is the numbers of the halogen atom installed in carbon, so will increase the strength of the acid. Okay, next we want to elaborate on the position. This one is the number of halogen, and this one regarding term of the electron withdrawing. Okay, number 1, and number 2, number of halogen atom. And the third one, effect of the position halogen atom on acid strength. Okay, as you can see here, I give you 3 examples actually. Okay, so this one our core skeleton carboxylic acid. Okay, as you can see the electron flow, okay, from positive charge towards to our element chlorine, which is high density of negative charge. Okay, so but here our electron flow towards to chlorine, which is far away from our core COOH. Okay, and lastly for this one, it's slightly far away from this one. Okay, it's showing that when your electronegativity in terms of element chlorine, fluorine, bromine, and others, all the element in withdrawing, when it's far away from the carboxylic acid, it's showing that your acidity become decreased. Okay, if your chlorine is nearest to the COOH, of course the pKa is slightly a drop or slightly decrease. Okay, the concept is simple. If you having your friend with the positive vibe, the positive aura, you become a great person. Okay, if you are having the friend in the circle of negative, of course, automatically you also influence their yeah, in terms of behavior, in terms of you like to do a negative perkara yang negative. Okay. So now, okay, finish in terms of withdrawing. Any question before I proceed for electron donating? Is it okay? So I hope you all okay. Okay, if I too fast, let me know. Okay, if you having a problem in connection or my connection, internet connection is not okay, tell me. Okay. Okay, so I proceed for the electron donating group, which is decrease the acidity. So it's slightly different to the electron withdrawing. Withdrawing can increase your acidity, but for donating, the groups decrease the acidity value. Okay, this is the example of my carboxylic acid. Okay, this is our COOH, and this one actually alkyl group. Most of the alkyl group, okay, alkyl group means that you having methyl, ethyl, phenyl, isopropyl. So all of these alkane and aromatic group actually is donating group. Okay, so this is a very simple to understand. Our carbon is positive. Okay, density is positive, and this one is positive. Also, this one positive and positive. So you actually provide a lot of positive charge to the nearest COOH. It's become the acidity will decrease. Okay, it's slightly different to withdrawing. You withdraw the electron, but donate means that you provide the electron. Okay, provide electron in terms of positive charge. Okay, so that's why the acidity will decrease. Okay, not only for alkyl group, we also having ethoxy group. What means by ethoxy group? Means that you having OCH3, methoxide, ethoxide, peroxide. So all of this is not stable. So once it's not stable, so what happened? The acidity is less decrease. Okay. So here is some of example. Okay, this table actually showing you all in terms of the effect electron donating group on your acidity. Okay, why I'm just mention about the acid strength, because this is carboxylic acid. Okay, so any explanation, any of synthesis reaction involving the acidity value. Okay, so that's why I want to give you understand the scenario of the effect of the electron donating and withdrawing on the acidity, because after this we can entering the lecture on synthesis and also reaction of carboxylic acid. Okay, so here the tables is regarding the example of electron donating. As you can see, this is our co-carboxylic acid. Okay, we have one alkyl group, this one we having two alkyl group, and this one three alkyl group. As you can see, we start with the basic of the acidity, we having one proton. Okay, or slightly lower the acidity. But when you are starting add on the alkyl group on your COOH, so what happened to your pKa means that your pH is become increased. So means that from acidic it will become to basic solution. Okay, basic strength. Okay, in acidity we don't want the basic strength, we want acid strength. So that's why in this elaboration, the most important is electron withdrawing. Okay. Okay, so we finish for our second part in carboxylic acid. Okay. Do you have any question? So far, so good? Or you want me to elaborate more?
Student, is there any question from students about the physical properties of carboxylic acid, the acidity, and the influence of electron withdrawing group or electron donating group? It's okay.
It's okay. So I think I just proceed.
Yes, please continue, Dr. Hidayah.
because this is online. If you come to my face-to-face, I like to walk around my class and to ask my question to my student, okay? But it's okay. This is international collaboration for teaching and learning. Thank you so much to learn my lecture today. Okay, so now we proceed for the synthesis of carboxylic acid. Okay, so we actually, there are lots of the synthesis and also reaction that involving the organic chemistry, because our surrounding, our industry, our in terms of research involving the lots of the reaction. So now we are focusing on the synthesis of carboxylic acid. Okay, so we have 4 syntheses of carboxylic acid. The first one, we have oxidation of primary alcohol and also aldehyde, alkene, and alkyl benzene. So we can elaborate more. And then hydrolysis of nitrile means that we add on of the carbon. And the third one, we want to do the carboxylation in terms of the Grignard reagent. We add off the carbon. And last one for malonic ester synthesis. Okay, we go through for the first one. Okay, we having this one, oxidation for primary alcohol, and also we have aldehyde, and we also have alkene and alkyl benzene. So the first one, the synthesis oxidation of primary alcohol. So before I proceed this chemical equation, so actually, do you know how to classify the primary, secondary, and tertiary of alcohol? You know?
Yes, we know,
Okay,
Doctor.
thank you. Okay, thank you so much. Okay, this one is the primary alcohol. Why? Because of this COH, if you can see, okay, COH. Okay, how many alkyl group bond to this COH? Actually, one. If one alkyl group bond to this COH, means that this is a primary alcohol. If you have two alkyl group bond to the COH, it means in secondary alcohol. And together with tertiary alcohol means that 3 alkyl group are bond to this carbon. Okay, but in this synthesis, oxidation of primary alcohol, we only focusing for primary alcohol. Okay, primary alcohol, we are using this oxidizing agent, okay, potassium manganate with acid. Condition should be heat. We need to heat. Why? Because of you want to form the C double bond O. Okay, that's why we need the condition of heat. Okay, or we can use the potassium chromate, we can use the chromate, this one. Okay, so this is the chemical reaction, okay, chemical reaction for oxidation of primary alcohol. So if you having the reactant, if you having reactant primary alcohol, okay, react with this any kind of oxidizing agent, so you will obtain the carboxylic acid. Okay, that's the number one. The number two is oxidation using aldehyde. Okay, we have our reactant aldehyde. Okay, this one is aldehyde. And then using any kind of oxidizing agent, this one. Okay, so we can get our carboxylic acid. Okay, for the third one, we want to oxidize our alkene. Okay, alkene, this is a special chemical equation because we having 2 types of alkene. Okay, so we have the germinal alkene, which is C double bond C. The bond C double bond is the middle of the structure. Okay, in the middle of the structure, the name is germinal. Okay, germinal. And the second one is terminal. So terminal means that you having the C double bond C, okay, double bond at the end of the terminal. It's likely the terminal for our destination. If you are using the airlines and using the bus at the terminal, same to this one. So terminal for alkene at the end of the structure. It's slightly different, right? So you must identify your starting material. Is it the alkene, the position in the middle or at the end of your structure of alkene? Okay, by using the potassium manganate, okay, we having the concentrated potassium manganate. If the germinal, what happen if you apply some heat? So you will get two mixture of product, which is carboxylic acid. And also this one, if you having the different alkyl group, but only one having proton, so you will form the mixture of ketone, or the other one is carboxylic acid. As you can see here, when you are using the germinal, okay, obviously you will get the mixture of product. Okay, it's slightly different to terminal alkene. When you are having this terminal, okay, structure, when you apply some manganate and also give heat, so you only get the one product, which is carboxylic acid, and together with the side product, carbon dioxide and water. Okay, so bear in mind, if you want to do you want to draw the structure by having this oxidation of alkene, make sure your starting material is it germinal or terminal. Okay, if terminal, you only form one product, but germinal, you only form the mixture of the product. Either you get both product is carboxylic acid, or you obtain one ketone, one carboxylic acid, or both in keto form. It depends on what kind of substituent alkyl. Okay. Okay, this is some example, okay, that I can show you all. This is our starting material. Okay, as you can see, this is a primary alcohol. Why? Because this one actually R group. Okay, only one R bond to COH, and of course this one is primary. And then you are using the manganate for the oxidation and apply some heat, okay, which is we want to recreate ataupun we want to form the C double bond O, so that you can obtain the carboxylic acid. And also this one is example for aldehyde. Okay, when you apply oxidation, so you obtain the carboxylic acid together with this one. This one is for aromatic. Okay, this aromatic we are using chromate. Okay, we will form the benzoic acid. Here is the example for the oxidation of alkene. As you can see, when we box this proton, this alkyl group, okay, when you box this one, so you will predict the mixture, your end product. Okay, but this one, of course, you will get the carboxylic acid, 2 carboxylic acid, and this one you will get 1 ketone, 1 carboxylic acid. And this one, when all C double bond C, this one having this one alkyl, means that there are 4 R group. So means that you having or you producing 2 mixture of ketone. Okay, lastly for this one is example for terminal alkene. So you will get the only 1 carboxylic acid together with side product and also water. Okay, so now we focus on alkyl benzene. As you can see from here, most of the reactant, I'm using the aliphatic carbon. Okay, this one is for alkyl benzene. We are using the same oxidizing agent. You can use any kind of oxidizing agent from the previous slide. Okay, but this one alkyl benzene oxidized to benzoic acid by when you heat in acidic CmNO4, or you heat sodium chromate, H2SO4. So what happen? You will form the carboxylic acid. Okay, this one we call alkyl benzene. Okay, but this scenario are slightly different. Okay, this scenario still having proton bond to this carbon nearest to aromatic. Okay, so remember this one. Okay, bond to this one. This one is proton, so that's why you get the carboxylic acid. But it's slightly different for this one. There are no benzylic hydrogen. As you can see, this is aromatic. Okay, join with the or bond with this carbon. And the surrounding of this carbon substituted with alkyl group. There are no proton substitute or bond on this C aromatic. Okay, so it means your starting material, there are no benzylic hydrogen. So what happens when you employing the oxidation reaction, so your end product, there are no reaction because there are no hydrogen atom bond to the carbon. Okay, there are no hydrogen. So please, after this, you can differentiate between alkyl benzyl with no benzylic hydrogen. Okay, so that you can give the right answer to determine the end product or desired product. Okay, so settle for the oxidation. So now we introduce you the hydrolysis of nitrile. Okay, as you can see, this is a chemical equation for hydrolysis of nitrile. Okay, we having this alkyl halide. And then we react with sodium cyanide. Why? Because we want to form intermediate of nitrile. Okay, this one is to form this one, intermediate. Okay, from this intermediate, we give or employing the hydrolysis, okay, with conditioned heat. So you will obtain the carboxylic acid with ammonium ion. Okay, so means that overall of hydrolysis nitrile, actually there are two steps. The first step, we want to producing this nitrile, and the second step, we want to producing the carboxylic acid. Okay, either your question asks you from starting this one, alkyl halide, or they can ask you from this one, or they can combine two steps to make sure you all get the end product carboxylic acid. Okay, so there are a variety of the question regarding on the hydrolysis of nitrile. Okay, this is some examples. So we have two hydrolysis, acidic and base. For this one is acidic. Okay, alkyl halide. Okay, react with sodium cyanide, you get the intermediate nitrile and proceed for the water. Okay, hydronium ion must be apply some heat here to make sure to form the C double bond O. Okay, we need some heat. Okay, and also our desired our side product ammonium ion. Okay, if your starting material starting from intermediate like this one, okay, Cn minus already substituted on the aromatic. So what happened when you doing the hydrolyzation? So supply some heat, so you will give the desired product is carboxylic acid. Okay, but this one still remain. Okay, but here different substitution. So please careful. Okay, sometimes student substitute on this position, both of this substitution. That's wrong. Okay, so this one is base hydrolysis. We having the intermediate RCN, but what the difference from the above? The above is we are using hydronium ion, which is preferred for the acidic medium, but this one is the basic medium. We have hydroxy ion, and of course we supply some heat. So what you get? You get this desired product we call as carboxylic ion with the side product ammonia. So careful during answer the question. Look at the structure, look at the reactant, and also the condition and reagent. Okay, next we look at the carboxylation, carboxyl of Grignard reagent. Okay, so when we call the Grignard reagent, means that in chemical equation, we have a metal, okay, RMgX, react with carbon dioxide with acid, then you will get the carboxylic acid. Okay, this reaction actually applicable to all this one, primary, secondary, tertiary, aryl benzyl, and aryl halide, mostly aryl halide. Okay, so what happened regarding on this reaction involve nucleophilic addition, nucleophile addition. This is the basic mechanism actually. We have this one alkyl group bond or attached with this metal halide and then react with the carbon dioxide. And then you will get this one we call as carboxylate ion. Make sure you draw the right structure. Okay, once this one when electron okay attack to this carbonyl, so what happened? O will become O minus, and this one will become MgX positive. This is we call as carboxylic acid. Carboxylic anion. And undergo and treated with the acid. So what happened? Will form the carboxylic acid. Okay, this is some example. You can look from my slide. Don't worry, I will give this slide through Ibu Siti. You just learn, you just enjoy the lecture. Okay, this one example for the Grignard reagent. Okay, magnesium chloride. Magnesium is metal together with chloride halide. Okay, so at the first step, we react with carbon dioxide and we give source of proton so that we will get the stable compound. If you didn't add this hydronium ion, so what happened? So actually, when you didn't give the source of proton in your reaction, so what happened is you didn't get your product, your end product. So it means that there are no carboxylic acid form. So you only form CH3, CH2. Sorry, my handwriter is so poor. CO minus. So you only form this one, not this one. Okay, but it's very important you give source of proton. Why? We want to stabilize this ion to make it the end product is in stable form. So what happened? Since I am a fellow researcher, okay, I'm doing the research in organic synthesis. What happened if you did not give the source of proton in your reaction? So what happened? When you having this solution ion in your reaction, so it's make it your ion will react with anything in surrounding your glassware. So that's why we need to give a source of proton, so you will form the stable compound. Okay, next is a malonic ester synthesis. Okay, this actually quite challenging for student. For the previous reaction, oxidation, in terms of Grignard, in terms of hydrolysis, is a straightforward reaction. But for the malonic ester synthesis, actually involving several of reaction. So how you want to tackle the question? Is it the end product is the carboxylic acid or the one the intermediate product? Okay, so we look at this slide. This one. If you see this one, malonic ester synthesis means that you want to producing. Kita nak hasilkan desired product apa yang kita nak. Okay, from our chemical equation, from the fundamental theory, sepatutnya should be when you are doing the research, you should be obtaining the desired product. This one, the malonic ester synthesis is your reactant. Okay, followed by hydrolysis and decarboxylation, you will get the carboxylic acid. Okay, this I step forward to the example. Okay, this one actually our malonic ester. So for those who still blur, still don't know what is the ester structure, this one is ester, our ester. Means that this malonic ester having two ester, okay, and bond in one carbon or bond with the aliphatic carbon. Okay, so we want to do the nucleophilic addition so that we provide the medium of nucleophile here, C minus. Once you having a nucleophile here, addition of nucleophile, what happened? So we proceed for the alkylation. Okay, we proceed for the alkylation. So once you proceed for alkylation with a source of proton, so this ester hydrolyzed. That's why the term is hydrolyzed, means that your ester should be in the intermediate or this transition state. Okay, and undergo for this halide, alkyl halide, whatever alkyl halide, maybe aliphatic halide or aromatic halide, and you give some source of proton. So you will hydrolyze two of this ester. Okay, you will get this dicarboxylic acid together with alkyl group substituted on this carbo anion. This one we call as carbo anion. Okay, so having this one is hydrolysis, right? Okay, and then we proceed for carboxylation. Decarboxylation. In terms of English, decarboxylation means that you want to remove the carbonate actually. So how many carbonyl you want to remove? So actually we only remove one carbonyl. So since we are having two carboxylic acid, two carbonyl, so it's up to you. You want to reduce this side or the other side. Both are true answer. Correct answer. Okay, so decarboxylate means of the methylene ester synthesis. We having hydrolysis and decarboxylation, and we want to creating substituted acetic acid. This one we call substituted. Substituted acid depends on what kind of alkyl halide that you are using. Okay, if you are using the aliphatic alkyl halide, then you are substituted with alkyl halide. Okay, to carboxylic acid. Okay, so this one is step by step. Okay, but this one, but the question can ask you in one short question. They give 1, 2, 3, and you provide the end product. Okay, so make sure read the question carefully, and then for me, organic synthesis is not difficult if you understand the basic. But the difficulty in organic chemistry, actually there are a lot of the reaction, and at the same time you are student, you not only learn of organic chemistry, you having several of the course code, is it? So you having 5, 6, so you want to learn in one time. Of course, you having a stress at the end of the semester. But if you manage to reschedule your study, and you make it this topic in group discussion, will be easier for you to learn the organic chemistry. Okay, now this is explanation regarding on alkylation, hydrolysis, and decarboxylation. You can learn after this. Okay. Okay, this one actually the same example, but different of different using alkyl halide. Is it the previous is sorry, the previous ester is ethyl ester. This one is methyl ester. Okay, but the concept, how we draw until you get the end product, actually same. Okay, so I leave it here, so you can see after this. Maybe you can discuss with your friends. Okay, currently there's AI era, so it will be useful if you are using the apps regarding on the tutorial. And if you don't understand, my tips is straightforward. Ask your lecturer when you are having the confusing during this organic chemistry. Okay, this is how the mechanism actually on the methylene ester. I don't know, is it this mechanism included in your syllabus or not? But after this, you can refer your lecturer, Ibu Siti. Okay, but this one I just give you. This is etoxide. Okay, base nucleophile. Okay, and then abstract this proton to become carbo anion. And after that, this carbo anion, abstract this alkyl, and this will become living group. Okay, what happened? Substituted at this one, alpha carbon next to the carbonyl. And then next, again, okay, this one example for two alkylation. The previous only one alkylation, but this one we having two substituted alkylation. It means that either they ask you using the same alkyl halide, or they are using the different of the alkyl halide. But we can substitute it with two alkyl group, okay? Because we having two proton here, and is logic that they can ask you by using two alkyl group. Okay, is either they are using the same alkyl halide or different of the alkyl halide. Okay, and then after the once you get the ester with di substituted alkylation, proceed for the hydrolysis and proceed for the, when you heat, you get what? You get the decarboxylation. So actually, you can try to do another tutorial and apply this mechanism. Hopefully, can help you to answer the question. Okay, so finish for our part 3, synthesis. Since now currently we are 2 o'clock, can I proceed the last part for reaction carboxylic acid, and after that you can ask me any question, or you can answer me in terms of the application of carboxylic acid, why you want to study this organic chemistry in your life, right? Because in UiTM we having the difficulty among the student to love the organic chemistry. So can we proceed for the last part, which is reaction of carboxylic acid. Okay, so
Yes, you can proceed it, Dr.
okay, Ibu Siti. So we proceed for the reaction of carboxylic acid. In carboxylic acid, we not having many of reaction, since this is the basic of the carboxylic acid. But if you learn the derivative of carboxylic acid, then the reaction, the synthesis become a lot. Okay. Okay, so the first one we study on the esterification, reduction, formation of hydrochloride, and lastly for amide formation. Okay, look at the esterification. Okay, we have carboxylic acid. Okay, react with any of alcohol, but this one we are using ethanol. Okay, we apply some heat here to get the ester. Okay, the ester product. Okay, so now we are transition from the synthesis. Synthesis means that you want to producing the carboxylic acid. For reaction means that your starting material now is carboxylic acid. Okay, and then by using several example of the reagent condition, then you will obtain the different of the product. Okay, so for esterification, when the name of the reaction is esterification, of course your main product is ester. Okay, we are using this alcohol and carboxylic acid. Okay, heat, you get the ester product. Okay, same to the aromatic benzoic acid. Okay, the second one, that's a simple chemical equation. No need to stress. The reaction is simple. Just practice a different kind of the starting material by add on the alcohol, heat, then you get the desired product. Okay, next is a reduction. If you learn from Ibu Siti, topic 1, 2 maybe regarding aldehyde ketone, you already understand the reduction reaction. Okay, in carboxylic acid, we also having the reduction reaction to produce we are producing the primary alcohol. The previous one, when you are synthesizing the carboxylic acid, you are using the starting material, primary alcohol, and then you get the desired product carboxylic acid. It's different for the reaction. You having reactant carboxylic acid using reducing agent lithium aluminum hydride in non-polar solvent. Okay, since our base in metal, we need to use the non-polar solvent to avoid any reactive reaction, and also to avoid any exploding happen. And then you will get the primary alcohol. Okay, here is the reducing agent, not only for lithium aluminum hydride. You can search from the reference book, from the Google site. So what is the reducing agent? Okay, should be in the dry condition. What happens if you are doing this reaction in moisture? So what happened is, so the lithium is very reactive. So once contact with the moisture, so dia boleh explode or anything lah happen when you involve the metal in your reaction. Okay. So here is benzoic acid. Okay, when benzoic acid, you are using lithium aluminum hydride, so you will form the alkoxide intermediate and adding water, so you can get the end product, which is primary alcohol. Okay, so there are two scenarios here. We are having the aliphatic carboxylic acid and also benzoic acid. Okay, for benzoic acid, we will get the alkoxide intermediate, this one. You get the intermediate alkoxide and give source of proton through the hydrolysis, so you will get the desired product, carboxylic acid. Okay, the next reaction that involved in carboxylic acid is formation. We want to form acid chloride. Okay, how we want to form the acid chloride? Okay, carboxylic acid. Okay, we know the co-skeleton general formula for carboxylic acid. We react with phosphorus chloride or sulfur. This one, example PCl5. We having SOCl2, or we call acetylene chloride. Okay, at room temperature, and we will form and we obtain our acyl chloride. Okay, as you can see here, our hydroxy substituted with this chlorine, this chlorine, and then you will get the acyl chloride. Okay, and of course, in case for benzoic acid, for this aliphatic, the condition only room temperature. Okay. This one for room temperature. Okay, if you are having the benzoic chloride, so what happened? You need to the condition should be in heat. Okay, you must apply heat. Okay, so we will get the acid chloride. Okay, so next is formation of amide. Formation of amide means that you want to form the primary amide. Okay, synthesize directly from carboxylic acid, but the yield is poor. So the better method here, you want to synthesize amide by using acid chloride. Okay, ammonium carboxylate will heated in the presence of free acid, dehydration occurs. So you will form primary amide. So it's special for to form the amide. Okay, we started with ammonium. This one is ammonium carboxylate, obtained by the reaction of excess carboxylic acid. This one, our second metal carboxylic acid will become the reagent, and we apply some heat. The heat also slightly higher, 100 to 200 degrees Celsius. Okay, and then we'll form here the desired product, primary amide, together with the side product, water. Okay. So this is, I think, the last slide from me. This is example for the secondary and tertiary amide. Okay, this is for the primary amide, and this one for the secondary and tertiary amide can be synthesized by using primary amine. Okay, the previous one, this one is ammonium carboxylate. Okay, react with excess of carboxylic acid. Okay, but this one, from the carboxylic acid, we react with the primary amine. How to classify the primary, secondary, and tertiary amine? So same to alcohol means that this is the amine. How many alkyl group? Okay, bond with this NH. If one alkyl group, then we classify this primary amine. If second, if we have two alkyl groups, so this is a secondary amine, and so on. Okay, so here if you want, if you react carboxylic acid with primary amine, you get the secondary amide. Okay, but this one, if you react the secondary amine, then you will get the tertiary amide. Okay, so I think that's all from me for this session lecturing. Ibu Ana.
Okay, thank you, Ibu Hidayah, for your presentation and your explanation about the synthesis and also reaction of carboxylic acid. So now we can discuss with the students. So students can ask to Dr. Hidayah related to this topic, or maybe you have questions related to University Teknologi Mara. Maybe Bu Hidayah also can answer it. So yes, please, students, maybe you have a questions.
I think the student they are not having my notes, so that's why I cannot recall for the beginning until the end of the session. But it's okay. Same to UITM student. Same to UITM student.
Oh yes, online classes maybe it's difficult to follow.
Maybe next time I can
Yeah.
go to Brawijaya.
Yes, of course, Doctor.
Student. Okay, no
Okay,
question. Mm.
no questions from students. Belinda, you want to ask something?
But it's okay because this is the theory and fundamental teaching. Maybe tomorrow you can ask me regarding application in my research. Okay.
Okay, yeah, if there is no question from student, tomorrow Dr. Hidayah will introduce about her research related to these topics. Maybe I also can inform to you that last year, the students from University Teknologi Mara come to Brawijaya to my lab and doing did a research around 2 weeks, I think, Doctor.
Yes.
Zayana,
Yeah,
2 weeks.
Zayana.
Zayana comes to our laboratory and did a research here. So maybe next time the student from Brawijaya have also experience to do a research in their doctor. Maybe tomorrow you can introduce some program from University Teknologi Mara about student mobility or etc.
Okay, can.
Okay. Okay, if there is no question from student, maybe we can finish this class, Doctor.
Okay. First of all, I would like to say thank you so much for your time and so your invitation for me to ITM. And I hope that from this teaching and learning, we having both student Brawijaya and also UITM. And then so see you tomorrow for next
Okay.
lecture.
Yeah. Okay. Thank you very much, Doctor. And see
Uh,
you tomorrow.
Ibu Siti, can we take a picture?
Oh yeah. Okay. So all of students, I hope you can open your camera so we can take a picture together. Sorry, Doctor, maybe you can end your slide or so okay. Yeah. Yeah, thank you. So I will take a picture. Please give a big smile.